let us start with diuretics today. So, what do you people know about a diuretic? कोई idea आप लोगों को पता हो कि diuretic होता क्या है? What is a diuretic drug? Any one of you?
सर इंक्रीज करती है यूरिन के वॉल्यूम को.
Okay, a diuretic drug. We'll be starting the diuretics. A diuretic is such an agent which increases urine output. Very good. इसमें एक चीज याद रखिएगा, एक चीज बहुत इंपॉर्टेंट. द फर्स्ट थिंग यू शुड रिमेंबर कि in our body the diuretics act by two ways. Usually the preferable way is that a diuretic agent actually does natriuresis. Natriuresis is loss of sodium from the body through the kidneys, and the water is in love with sodium and it goes behind it. So actually majority of the drugs do majority of these drugs, they actually do natriuresis. Natriuresis and diuresis follows. तो natriuresis कर दी, diuresis हो गई. बहुत कम एग्जांपल्स हैं हमारी बॉडी में जिसके अंदर हम एक ड्रग को विदाउट बीइंग अ natriuretic उससे diuresis करवा सकें. For example, an osmotic diuretic known as mannitol. We'll go in that detail afterwards. Majority of these drugs follow these rule. तो अब इसके अंदर हम इसको स्टार्ट करते हैं. And to start this, we'll have to look about small details regarding the body. If I symbolically represent this figure, this is the heart. If this is the heart of the body, the blood volume which the heart pumps in a minute is known as the blood volume which the left ventricle pumps per minute is known as
कार्डिक आउटपुट.
cardiac output. So actually, what does the heart make? The heart makes a cardiac output. And what's its value?
5 milliliter per minute.
No, 5 ml per minute. No, 5 liters per minute. 5 liters per minute. Of this 5 liters per minute, large portion, a very large portion is delivered to the kidneys. And it is known as renal blood flow or renal plasma flow. So the thing which is delivered to the kidneys is renal blood flow, renal plasma flow, we say it also. And what is it? It is approximately, does any one of you know? 1100 ml per minute, which is roughly 22% of the cardiac output. So it's a very large share. The kidneys are so small and they receive a large amount of blood. And out of this, the thing which moves into the nephron is known as glomerular filtrate. Glomerular filtrate, which moves into the kidney. And it is designated by a rate, which is per minute, obviously, glomerular filtration rate. And it is, according to our physiology text, it is 125 ml per minute. And more than 99%, 98% of this fluid is reabsorbed, and the remaining is pushed out through the kidneys, moved out through the kidneys in the form of the urine, and the urine output is roughly, does any one of you know? It is 1 to 2 ml per minute. So this is the normal urine output. And now if we just talk about a small thing, उसके अंदर मैं आपको एक और चीज बता देता हूँ. Okay, we can just make 2 lines here. Simple. The normal urine output is in this range. Does any one of you know the range? Daily, per day. Does any one of you know?
50 ml.
500 ml. No, it is very low.
Oh, 500.
500 ml per day is the lowest possible normal range. Just move it here. And the maximum usually is 3000 ml or 3 liters per day is the normal maximum peak. And in this between we get the normal between of these two values, this is the normal urine output. Output per, obviously, day, per day. Below this, what do we get? Below this, what is this?
Oliguria.
Oliguria. Yes, very good. And so we can write it here also. Okay, below the 500 ml per day value is oliguria. And when the urine output virtually reaches to 0, it is anuria. If it is 0 ml per day, so it is known as anuria. And what about the R range? These are average values. Remember, depending on the seasons and the climate, the value can fluctuate greatly. And above this, what is this known as? This is known as
Polyuria.
polyuria. Excellent. And the major thing, which I just told you, that if the body wants to retain water, it will retain sodium. The water will be retained also. And if the body wants to move water out of the body, it will do natriuresis, and the water will go after it, and the water will be lost. So it's a very simple rule. And now, when we start about the diuretics properly, we just have to draw a small symbolic presentation. We'll just draw a small figure, which will be easier, that this is the nephron. This is the Bowman's capsule. What is the part of the nephron which is coming after the Bowman's capsule?
Proximal straight tubule.
The proximal convoluted tubule. Then comes the descending limb of Henle, and then the ascending limb of Henle. And the ascending limb has two parts. Does anyone of you remember? The thin ascending and the thick ascending part. And after the thick ascending, again comes the distal convoluted tubule, in which your joins to form a collecting duct, and many collecting ducts will ultimately fuse to form a larger collecting ducts. The smaller ones are known as cortical collecting ducts, and larger ones are known as medullary collecting ducts. And the urine output will be formed. So we have a large group of diuretics which act on the nephron. Does any one of you know? The first group of nephrons acts here on the
Carbonic anhydrase
proximal
inhibitor.
convoluted tubule. We'll just label it by the way. This is the PCT, and here the diuretics which act are one of the carbonic anhydrase. We'll just make it a bit small. The carbonic
anhydrase inhibitor.
Anhydrase. Yes, very good. Anhydrase inhibitors. And the next one, does any one of you know, or want to tell me? The next group acts on the
Thick ascending limb.
thick ascending limb of Henle. So here. And in this area, the diuretics which act are known as, this is the
Loop diuretics.
very good. This is the thick ascending limb of Henle. And here, sorry, the drugs which act are known as the loops, the loop diuretics. And now this, in the next area, we'll draw it in a black color. Let us choose it. The proximal half of distal convoluted tubule, the proximal half of distal convoluted tubule, this area. This is the proximal half, not the complete one. Proximal half of GCT. The drugs which act here are thiazides, thiazide
diuretics.
diuretics. Very good. And the ones which are acting on the next area, which include this part also, the remaining half of the distal convoluted tubule, as well as the collecting ducts here, as well as
Osmotic diuretics.
No. Here, these are the potassium sparing.
Aldosterone.
The distal convoluted tubule, last half, distal half of DCT, of distal convoluted tubule, and the cortical collecting ducts. Here acts the potassium sparing. Diuretics. So these are the areas, and yes, for your information, we can add that ADH also acts on the collecting ducts, but it is not a diuretic in fact, but we will be studying it in this chapter also. So now let us start with the first diuretic. The first diuretic, which is the carbonic anhydrase inhibitors, the number 1. Does any one of you know the names of these drugs? Examples? A very famous one. Acetazolamide. Anyone else?
Dorzolamide and brinzolamide.
Dorzolamide and brinzolamide. But the thing to remember is, these are the major drugs which are used. But the thing to be remembered is that the last two are only topical. The last two are topical, are not given systemically. They are given topically for glaucoma only. The first one is the major drug which is used for all purposes, the remaining purposes. Now we'll go towards the mechanism of action. Does any one of you know what is carbonic anhydrase enzyme? Now look, we are saying that these drugs are carbonic anhydrase inhibitors. आप में से किसी को पता है carbonic anhydrase enzyme होता क्या है, करता क्या है?
So, बाइकार्बोनेट की रीअब्जॉर्प्शन और सेक्रीशन के लिए नेसेसरी होता है.
Okay.
किडनी के अंदर
The simple equation which we have been studying from years, that H2O plus CO2 is equal to H2CO3, is mediated by an enzyme known as carbonic anhydrase. And the reverse of, as this reaction is a reversible reaction, the opposite thing from H2CO3 to H2O and CO2 is also done by carbonic anhydrase. So let us draw this part of the nephron. It will take just a minute. If this is the nephron and the urine is coming, we are just making the proximal convoluted tubule and we are straightening it. And we have a cell here which is on this side, which will be reabsorbing the water or whatever is to be reabsorbed here. Okay. Now this part represents the urine. This is the blood. And the surface, has any one of you ever named the surfaces of a cell? This is the apical surface. And this one is the basolateral, towards the basement membrane. This is the basolateral surface, this is the apical surface, and here is the blood, which will be reabsorbed, and this part represents the urine. This is the cavity of the nephron, okay? Okay? Now what happens is that the carbonic anhydrase enzyme is located somewhat here. Here it is located, which is known as carbonic anhydrase enzyme. Actually, it is present inside the cell as well as outside the cell. So we will make a single box which will represent the both parts. So we can label it as carbonic anhydrase, CA. That I guess this will be simply understandable. Now what happens is, two things are majorly coming in the urine in this part of the nephron. Number one, can any one of you tell me? I'll just make it small. Can any one of you tell me what are the major things which are coming here?
so sodium chloride and sodium bicarbonate.
Okay. We can say, okay, let us write. The first thing which is coming here is bicarb, HCO3. Okay, we do not have the option. Okay, the second one is sodium And the third one is obviously water. Just understand, we do not have the option of making it in small. Okay, now what happens here? If we just leave behind sodium and water, what happens to bicarbonate? Bicarbonate joins with hydrogen and forms HCO3 plus hydrogen. What will be formed? Tell me. H2CO3? Is it okay? H2CO3. And now the carbonic anhydrase enzyme actually splits it into two. The carbonic anhydrase will act on the H2CO3 and it will split it into two things. Can anyone of you tell me? Carbon dioxide and please tell. Water. Now carbon dioxide is a lipid soluble gas. It will easily move inside the cell. It will move by simple diffusion. It will move inside. And again, this CO2 will bind with more water in the cell. H2O plus CO2. And what will be formed? Tell me. Can any one of you tell?
Sir, again H2CO3.
This will form H2CO3 again. And the thing which will be forming it is again this enzyme, this carbonic anhydrase. It will act and it will convert it back into H2CO3. Now what we get here is H2CO3. Now H2CO3 will again split into two things. One is bicarbonate and the other is hydrogen. This is hydrogen and here is HCO3 minus bicarbonate. Now what happens is, now we come to a pump. A rounded thing represents a pump. A rounded thing represents a pump. And this pump will make it in another color so that we're not confused. A pink colored pump which is known as sodium hydrogen counter transporter. What is its name? Sodium hydrogen counter transporter. And it pumps this hydrogen out, and actually this sodium inside the cell. What is this? This is sodium. Now what will happen? The sodium is simply taken up by the apical surface through again a pump, which is known as the famous one. Does any one of you know the famous pump which picks up sodium?
Sodium potassium
ATPase. Yes, this will be moving out through the sodium potassium ATPase pump through energy, and the thing which will be moving inside it is known as potassium. Now what is happening here? I guess you can understand what is happening. I guess no one will ask you to make this figure, but you should understand it like this. Now this is the normal thing which has happened, which is happening in our body. When we give a drug which is known as sodium potassium carbonic anhydrase inhibitors, it will block this thing. So we can say that this carbonic anhydrase will be blocked. By giving a drug, this happens. Now what should be the results? We'll write them in a red color. What will be the results? Tell me. What will be lost here? Can anyone of you tell me? H2CO3. Will it be lost in the urine? Please answer.
No, sir.
Why not? Now look, this carbonic anhydrase is blocked. This H2CO3 will not be broken. If it is not broken, it will be lost in the urine. Got it?
Yes, it will be lost. Yes, sir.
Okay. And now, when this pump will be blocked, again, I'll use the spotlight. When this pump will be blocked, no H2CO3 will be formed inside the cell as this carbon dioxide is not available. And when there is no H2CO3 here, so there is no hydrogen here. And when there is no hydrogen, this pump will be blocked as well. So no sodium will be moving inside the cell and no hydrogen will be going here. So what will be the next thing which will be coming in the urine? Shabash.
Sodium.
And the next thing, again, sodium will be taking a lot of water with it because water is in love with sodium. Where the sodium goes, the water follows. So these three things will be majorly lost in the urine. Do you understand it now? And what will be retained in the body? Can any one of you guess? Just guess. It's just
Calcium.
okay. Potassium. Yes, very good.
Hydrogen.
Hydrogen. So this diuretic does acidosis, and because it is also, you can see here, it's losing a weak acid or an alkali HCO3 in the urine. So what are its uses? Now we'll go towards its uses. समझ आ गया बेटे? Any question? So what should be the uses? First of all, remember one thing, it's a weak diuretic. It's a weak diuretic, remember this thing. Or I can say the weakest of all. Why? Because the remaining nephron is after its territory, and there are a lot of places where the water and sodium can be reabsorbed afterwards. It's a weak diuretic. So first use is in glaucoma. What is glaucoma? When the intraocular pressure of the eye is increased due to more aqueous humor, either it is due to more production or due to decreased drainage, which has two types, open angle and closed angle, if you remember, glaucoma. Okay. Number two, anyone? Altitude sickness or mountain sickness. Number three, alkalosis, maybe metabolic or respiratory, majorly metabolic, because respiratory alkalosis is a very rare presentation to see. And what can be done with it? Can we alkalinize the urine? Can we do it? Can we alkalinize the urine because the alkali is being lost in the urine for urinary alkalinization? And pseudotumor cerebri. Has any word of you heard about this name? Pseudotumor cerebri. And do you know what does it mean? Pseudotumor cerebri. Shabash. Anyone? I'll wait for your answer. No? Actually, it is increased intracranial pressure. Increased ICP resulting in headache and cerebral edema, and the patient presents as a tumor-like effect. Pseudo means false. A false tumor of the brain, which is actually due to increased intracranial pressure, and we can lose the extra water here in the urine. Okay? So any question? Any question?
No, sir.
And now here I should add, these are the uses only of acetazolamide, not of doryzolamide. That they are only topical. They are only dorzolamide and benzolamide. They are only topical and they are used for glaucoma, the first one only. Here in front of glaucoma, we can add dorzolamide plus brinzolamide also. The remaining uses are only for acetazolamide. acetazolamide. What should be the side effects or toxicities? Can any one of you guess?
Sir, acidosis.
Okay, very good. Metabolic, because it's acting on the kidney, we'll say metabolic acidosis. Number one, very important. Number two, remember this is a sulfur drug, and sulfur drugs are notorious for allergies. Okay? So sulfur allergy. These drugs are sulfur derivatives. Sulfur allergy, we say it in common practice. Sulfur allergy. It causes paresthesias and ammonia, NH3 toxicity, ammonia toxicity. So these are the major side effects. And yes, partly sedation also. It is not such a strong diuretic which can cause hypotension or increased volume loss. No, it will not do it. Or orthostatic hypotension, it will not do it. Reflex tachycardia will not happen. That can happen with a stronger diuretic. So I wrote it first that it's a weak diuretic. So any question up till now? Any question? Okay, so we'll take a break of 2 minutes and then we will start the next diuretic. 2 मिनट देखें इसको, ये इंपॉर्टेंट चीजें हैं, थोड़ी सी मुश्किल हैं टेक्निकली, इनको देखें बेटा, मैं फिर इसको आगे लेके चलता हूँ, ठीक है? समझ आ गया बेटा? किसी का कोई सवाल है तो जरूर ढूंढ के रखें, मैं इसको आगे लेके चलता हूँ, फिर थोड़ा सा लगाना पड़ता है. Okay, so now we'll move towards the next diuretic, which is the loop diuretics, and they act on the thick ascending limb of Henle. We wrote them in a blue color, so we'll use the blue color same. The loop diuretics, very important. And remember one thing, the loop diuretics are the strongest diuretics. So remember it, they are the strongest diuretics which we have up till now. So it's an important thing to be remembered. Examples, can any one of you dictate me a small list of examples? There are not so many. The most famous one, furosemide, in the Lasix tablet, Lasix injection, you see furosemide. Bumetanide, and then does anyone of you know anyone more? Torsemide.
Ethylgranic acid.
Very good, ethylgranic acid. This one is important. This one is important that because it is the only one which is not a sulfur drug. Remaining all are sulfur drugs. So this is a bit specific one, a different one. Okay, beta? Now, where do they act? Now we'll draw the same figure like this. They act on the, please anyone tell me, the thick ascending limb. We'll draw it here, a bit larger figure. And I'll be making 2 boxes here. And the reason I will tell you afterwards. You'll understand the reason. These are 2 cells of the thick ascending limb. Again, this part is what? This is the urine. And after reabsorption from the apical surface, here is the blood. Okay. And now the direction of flow will make down upwards. In this part of the body, there is a pump, which is known as 1 sodium 2 chloride 1 potassium pump. What is the name of the pump? 1 sodium 2 chloride 1 potassium. And what is happening here? Obviously, 2 things will be going, 3 things, sorry. We'll make it a small one. It is a big one. This pump absorbs 1 sodium, 2 chloride, and 1 potassium. We can simply write sodium. How many chlorides did I just say? 2 chloride. and 1 potassium. So these are the things which are reabsorbed here. What happens is that the sodium, again through the pump, what was the pump? The famous one, which is present on the apical surface. The sodium.
Sodium potassium.
Yes, very good. The sodium potassium ATPase pump. It will move the sodium into the blood. The sodium will go into the blood, and what will be coming inside? Potassium. At the expense of what? 2 potassiums. The thing moving out is obviously sodium, and which are actually three sodium out, and how many potassiums in? 2 potassium inside. Now, if you just see here, that in this part of the cell, there is an excess of potassium, and to get rid of that potassium, there is a channel which is present in the cell, which is actually a leaky channel, and this channel allows extra potassium to move out of the cell. This extra potassium will come here, and along with this, potassium, it will be lost in the urine. This extra potassium will be lost in the urine. So what will we get here? Here will be a lot of potassium. Will it be so? And a lot of positive charge, in fact. The potassium will be creating a large amount of local positive charge in the urine. Is it clear? Now what happens now? In the urine, there are 2 more things which are coming in this direction towards the output. Does any one of you know the names?
So calcium and magnesium.
Very, very good. Very, very good. What will happen to them? The things which are coming here are calcium 2+ and magnesium also 2+. They will be repelled by this positive charge, and they will find a way out between the cells here, and they will be absorbed into the blood through this intercellular space. So this calcium and magnesium will be going into the blood like this. Calcium and magnesium. So in this part of the nephron, look, a lot of things are reabsorbed. Sodium is reabsorbed, chloride is reabsorbed, calcium is reabsorbed, magnesium is reabsorbed, and obviously with sodium, water is reabsorbed. But the thing which is lost is potassium in the urine. Okay? Now, do you understand it now? What happens here? When we gave these drugs, they block this pump. This pump is blocked. Now, what will be the things which will be lost in the urine of the patient who is taking the drug? Tell me. Number 1.
Sodium, water.
Will be a bit systematic. First one will be sodium, and along with sodium, what will go? Sorry.
Water.
Very good. Sodium and water. And the next thing, chloride, should it be? And the next thing, calcium, should it be there? And the next one, obviously, magnesium, should it be lost? बताएं?
Yes, sir.
ठीक है, तो बहुत सारा कुछ लूज हो गया. And even potassium. Why not potassium? Potassium भी तो जाएगा ना from this pump. If we have blocked this pump, the potassium will also be lost. So we can add it here. Potassium will be lost as well. So a lot of things will be lost in the urine. Sodium, water, chloride, potassium, calcium, and magnesium. So I can say this drug is causing hyponatremia, hypovolemia, hypochloremia, hypokalemia, hypocalcemia, and hypomagnesemia. So a lot of hypos. Look, okay? So what should be the uses? The uses of the drug, as it is a strong diuretic. What should be the uses? Heart failure. In the left heart failure as well as in the right heart failure. And what if both hearts are failed at the same time? We say it congestive cardiac failure or heart failure. So not only in the left right? As well as congestive cardiac failure, CCF or CHF, we write it. Okay, will you understand it? Left heart failure results in an edema in the lungs. What is it known as? The famous pulmonary edema. Should it be given in it? Generalized edema due to right heart failure. Generalized edema of the body due to right heart failure. Ascites. It is not a drug of choice, but yes, we can give it in a patient of cirrhosis who has ascites. It can be given. Usually, the potassium-sparing diuretics are preferred in that case. So we just write it here because bookish or theoretical, we have to know all of the uses. Does any one of you guess? Can any one of you guess any other cause? In a patient of kidney failure, when the urine output is decreased, we can give a trial of this to increase urine output, for example, in nephrotic syndrome. Hypertension, can we use it in hypertension? Yes, it is a very good drug to be used in hypertension as it will decrease the blood volume. And in hypercalcemic states, hypercalcemia, can we give it? Hypermagnesemia, can we give it? Yes. All of these conditions are those in which this drug is used. And what should be the toxicity of this drug? Can any one of you guess?
सर ये ऑटोटॉक्सिसिटी कॉज करती है, रीजन नहीं पता.
Okay, reason nahi pata. Okay, first of all, we will talk about the major things. Can it do hypovolemia? As it's a strong diuretic. Yes, it can dehydrate the patient.
Metabolic alkalosis.
Okay, why? I do not get it.
Sir, hypokalemic ho jata hai.
First be here. Hypocalcemia. Will it cause hypocalcemia?
Yes, sir.
And will be the calcium increased in the urine?
Yes, sir.
Can it cause hypomagnesemia? Can it cause hypokalemia? So these are the major side effects which we can just guess from this figure. And now the remaining, yes, it is autotoxic. Sorry. Yes, it is autotoxic. And it causes gout, a famous side effect. You can remember it from the joints. And can it be osteoporotic? Because it is losing the calcium from the body. If we can add it here, it can increase or it can potentiate osteoporosis. An old female patient which is suffering from osteoporosis, we should try to not use this drug or use it in a combination, for example, with a thiazide diuretic, as it increases the blood calcium. And it causes nephritis. And the last, not the least, sulfur allergy. And sulfur allergy is notorious, except with the drug which is, please tell, except ethacrynic acid. Except ethacrynic acid. So this is the major use of this drug. So any question up till now, many beautiful people here? जी मुझे बताएं, कोई सवाल है तो पूछें.